All right, we're back, and after a long discussion of how breathing works, we're going to talk about how that breathing feeds into actual speech, primarily through pulmonic aggressive sounds, and what the flow of air from the lungs does to your larynx, or what your larynx can do to it. Might be another better way of thinking about it. So today, I'm going to talk about vocal fold physiology first, and then talk about the various forces that come into play in the various actions of the larynx, and how that ultimately feeds into voice quality, which is a set of lectures I'm going to record tomorrow. Not that you have to worry about that, but it will be something I expect you to watch after the next set of 3 video lectures. So let's get into it. And like I said, we were talking about how we get air out of the lungs and then pump it up through our trachea, which is here on the diagram. And I think I mentioned this during the lecture on respiration, but when air comes out of your lungs, it goes through one of these 2 main passageways from each lung, which is, these individually are called a bronchus, or the bronchi, plurally. And then those connect up to the trachea, which is informally known as your windpipe, which you can feel in your throat, or you should be able to feel it, hopefully. If you can't, you might want to see a doctor, and not the PhD type. But the trachea is down here at the bottom of your throat, and you can feel it has basically a stack of cartilaginous rings, which more or less protect the inside of the trachea, which is an open pipe, so that air can flow through it. So on top of that is kind of the important part that we want to discuss today, which is the larynx, which is hiding behind this cartilage right here. Hopefully you can see it reasonably well on my throat. It comes to a nice little point here, and it's colloquially known as the Adam's apple, and below that is the trachea. You can kind of feel those ridges of the trachea right there. And the interesting part is that this is where voicing happens, as we know from our previous study of 341. What exactly goes on with voicing, though, is we're going to talk about today. So the larynx is a complicated structure consisting of a variety of muscles, ligaments, and 3 primary cartilages. So my plan for this first lecture in this set is to just kind of walk you through the framework, the mechanical framework of the larynx, talking about the various parts and how they kind of fit together. So as was the case with the lecture on respiration, there's going to be a fair amount of just technical terminology that we're going to have to learn here. A lot of these important terms are already listed here, but I'll walk through them one by one as we go. And again, you can write down notes if you want to, or you can review the tape as many times as you need to try to learn the names of these things. After that, we'll talk about how they actually move around and how they affect the flow of air in phonation. Okay, so let's get into it. The larynx itself has 3 primary cartilage structures, and the one that kind of forms the foundation or the base of the whole system is called the cricoid cartilage. So again, this diagram is showing you the very top of the trachea. And like I said, you can feel those rings of cartilage at the top of your trachea. There's, I guess, membranous structures that kind of fill in the gaps between them. And sort of the very top ring on top of the trachea is sort of the bottom of your larynx. And it's a specialized cartilage known as the cricoid cartilage. You can't really feel it. There's a different cartilage here in front of it, which gets in the way of you being able to feel your cricoid for good reasons. So don't try too hard to kind of get your fingers around it. But this one, again, sits on top of these tracheal rings. And the idea is that it kind of looks like a signet ring, which is where it gets its name from. So there's an ancient Greek word, krikos, which means ring. So this is the cricoid cartilage. And what I mean by a signet ring is like one of those fancy rings that perhaps you got when you graduated from high school, I don't know. But it kind of has like a flat surface on it, and then the rest of it just fits around your finger. So back in the old days, apparently what they would do is melt some wax. Like if they had written a letter and put it in an envelope, they could melt some wax, then like dip their signet ring in it, and then seal the envelope with the wax by pressing it down with their finger or the ring on their finger, and then it would have their seal on it as well, whatever specialized seal they might have. I guess that might have been just the the fancy way of doing it, but either way, that's where the name comes from. And the idea is this looks kind of like a ring, more specialized ring than this, which is sort of like the Lord of the Rings ring, because it has this kind of ring-shaped structure here, then it has a flat spot at the back. And the back of the cricoid cartilage is the posterior part of your neck, basically. So anterior is sort of the front of your body, posterior is the back part of your body, right? So this cricoid cartilage does not operate by itself. Like I said, it just provides the foundation for this whole system. And it has what are called facets, which connect it to the thyroid and arytenoid cartilages. And we'll talk about those next. But the facet, what is meant by that is basically a kind of depression in the cricoid cartilage itself, where it can make kind of a connection or a junction with other cartilaginous structures. And we'll see them in a second. And I'll also point out this flat part of the back is technically known as a lamina, like a smooth flat surface, like laminate. We talked about that a bit in 341 when we talked about laminal consonants. So the back part of this is just the cricoid lamina. This is called the cricoid arch. I don't think you have to worry too much about that. What I do want you to worry about is what sits on top of the cricoid cartilage, which is the thyroid cartilage. And this is the structure that you can feel in the front of your throat. So this is known as the thyroid cartilage because it comes from another ancient Greek word, thyreos, which means shield. And that's an appropriate word for it because it basically protects all the sensitive, important structures in your larynx from the outside world. It's not a bone, but it's pretty hard, right? It's cartilage. And it blocks anything coming in, well, to a certain extent, from the front of your throat from damaging those structures. The thyroid cartilage has horns, of all things. Both lower part of your body is known as inferior. The upper part of your body is known as superior. So it has both inferior and superior horns. We'll see them on the next slide. And the lower horns connect with the cricoid cartilage at the cricoid's lower facet, so down here. And the upper horns connect to the hyoid bone, and hyoid is a word that I often struggle to say correctly because it's got two amazing diphthongs right next to each other, but I've done it twice. I don't know if I want to try it a third time. But you can feel the hyoid up higher than the thyroid cartilage. So the hyoid is interesting because it's the only bone in your body that's not directly connected to another bone in your body. But it is connected to your thyroid cartilage, which is kind of fun. And you can kind of feel it if you push up from this point. There's kind of a bony structure up here, and that's the hyoid. That doesn't really get that involved in speech production, so we're not going to worry about it. I'm just letting you know this is where these two horns go to. So these are the upper horns, or as they're labeled here, the superior cornua. I got all the way through hyoid like 4 or 5 times, but couldn't make it through superior. Anyways, the lower horns are down here, and they link up to the cricoid cartilage here. So this whole thing kind of sits on top of that structure with a loose joint that can the thyroid can kind of rock around. So there's a few other structures here which are kind of worth paying attention to briefly. So like the cricoid lamina at the back of the cricoid cartilage, the thyroid has 2 laminae, or flat surfaces, which kind of come to a point, which is what you can really feel in the front of your throat. So this is what they call it a thyroid prominence here, and then there's a thyroid notch. So you can actually probably feel that there is a little bit of a gap. If you press down on top of that point in the middle of your throat, you can kind of feel a little bit of soft spot where you can kind of feel the emptiness in between the 2 laminae. But overall, this whole thing is known as the thyroid cartilage. Okay, so this reiterates what I just said. The 2 broad flat front plates of the thyroid, the laminae, meet at the thyroid angle. And the angle of the thyroid angle, the actual geometric angle of the thyroid angle, tends to be more obtuse in women than it is in men. So normally for guys, this is going to point out a bit more than it does for women, but it's there in both sexes. So you don't have to worry too much about that. It just might be kind of harder to feel that sharp point in women. Otherwise, this doesn't have a whole lot to do with speech, although maybe it gives more space or more length for what's inside here, as men tend to have longer vocal folds than women do, and perhaps that's just a correlate of why that is the case. This is also going back to the ancient times, perhaps why this is called the Adam's apple, and there's a story that goes along with that I'm not going to get into right now, but it's named after Adam, who was supposed to be the first dude, perhaps because this structure is more prominent in men than it is in women. All right, so there are also two arytenoid cartilages. The name arytenoid comes from the ancient Greek word arytaina, which means ladle, and these are kind of like upside down ladles. So here's the cricoid cartilage, and this is looking from the back towards the front. Here's the side view. The arytenoid cartilages, there are two of them. This is sitting behind the thyroid cartilage here, and at the back of your cricoid cartilage, and their spoon kind of shaped structure sits on top of these bumps at the top of the cricoid cartilage. And if you look at them at the side view, you can see that in addition to having this kind of spoon shaped structure at the bottom, they have a point in front and they have a point at the top as well. And these two guys kind of get close to each other at the top as well. These are, I'll just describe them as small and pointy and sit on the backside or lamina of the cricoid cartilage. And these are the guys which are kind of the main movers in phonation when we're actually getting the larynx involved in speech. The thyroid moves to a certain extent. The cricoid doesn't move at all. These guys move a fair amount. Okay, so the three cartilages are connected by a variety of muscles and ligaments. The most important of these are the vocal folds. So they live at the very top of the trachea in between the cricoid and thyroid cartilages. And I'll walk you through a diagram of these in a second, but I'll just point out before I get there that the vocal folds are a combination of both a muscle and a ligament. The muscle has the technical name of the vocalis muscle, for reasons that hopefully are obvious, and the ligament itself similarly has the name of the vocal ligament. The vocal folds themselves are enclosed in a membrane called the conus elasticus, and I think this all will make a little more sense if you see the diagram, so I'll just show that to you here. So these are the vocal folds, and we kind of considered them when we were looking at diagrams in 341 to learn how people actually voice or phonate. Technical distinction here. So first of all, these are kind of nubbins on either side of your glottis. Excuse me. So this is kind of looking through the larynx this way from front to back or back to front. It doesn't really matter that much. But the one here on the right, you can kind of see this is the muscle part of it, the vocalis muscle, and this is the ligament part of it here at the very edge. And then technically speaking, the glottis, usually we talk about the larynx or the vocal folds or the glottis kind of interchangeably in 341, sort of like people often talk about Britain, UK, and England all have the same, meaning the same thing, but they don't. The glottis does not mean the larynx or the vocal folds. The glottis is actually the space in between the vocal folds. And then here's one vocal fold on this side, and here's the other vocal fold on this side. And the combination of muscle and ligament is enclosed by this conus elasticus membrane to get them to kind of work together. I'll show you some videos of this. Again, going back to the visits to the cadaver lab, if you've had that, the fortune of being able to go there. When you see the ligaments themselves, the vocal folds themselves, they look kind of that pale gray color, which is typical of ligaments in the body. So they seem like they're more like ligaments than muscles. And hopefully you'll be able to see that a little bit in the videos I show you, although those videos aren't the clearest, unfortunately, but they do get the job done. So I will also mention here that these are called the true vocal folds in this diagram to contrast them with what are called the false vocal folds, which sit a little bit higher than the structure here, the glottis itself. So these are sometimes called the false vocal folds. They're also sometimes called the ventricular folds because there's a little kind of empty chamber in between the two sets of vocal folds that is technically known as the ventricle of Morgagni. Also kind of taking a step back here, you can see two of the cartilaginous structures in the larynx. So here's the cricoid, which is the foundation. Here is the thyroid cartilage itself, and this is the highest ring in tracheal ring in your neck as well. And this just reiterates again that the glottis is technically the space in between these vocal folds. Okay, so this is looking from top down onto the larynx itself and the vocal folds too. So this shows you how they link up to between the thyroid cartilage. So here's that point again at the front of your body, and then inside the larynx where you can't feel them are these arytenoid cartilages sitting on top of the cricoid cartilage. And at the point of each of these arytenoid cartilages, which the point that's pointing forwards, you get a link up between the vocal folds and this notch in your thyroid, basically, or the angle of your thyroid. Here is also to specify the conus elasticus. This membrane kind of fills in this gap here, and the glottis again is this empty space between the two vocal folds or vocal ligaments. Yeah, so hopefully you can see here why the arytenoids are going to play an important role in this, because they're part of what connects the vocal folds to the thyroid cartilage. I'll also point out that, speaking of this glottis, this empty space in between the vocal folds, you can divide it into two different parts because you can actually control the two different parts relatively independently. So between the two vocal folds or the vocal ligaments, you have what is called the ligamental glottis. And then at the back, between the two cartilages itself, this little gap here is known as the cartilaginous glottis. So this whole glottis consists of two different parts. The cartilages are not a flexible material. They're relatively hard. The vocal ligament is a little more spongy, I guess, and so it can kind of bounce back and forth as it normally does in phonation. But you're not going to get the Bernoulli effect with the cartilages here. Yeah, so just keep that in mind. What do the arytenoid cartilages do? They can be moved with respect to the cricoid cartilage in two different ways. On the one hand, you can kind of rock them side to side. So if you think about them, actually, something like this, and I don't know if you can see that. This is kind of how they're structured, and you can kind of rock them back and forth towards each other. And then you can also kind of push them forward down the cricoid cartilage like this. So they're moving closer to the thyroid here. In this case, they're either rocking towards or away from each other. And in this case, they're just moving either forward, closer to the thyroid cartilage, the front of your larynx, or the back of moving backwards away from it. And you can do both of these at the same time or independently. So the rocking motion is going to abduct or adduct the glottis. So abduct means to pull away. The ab here means away, and the ad means to. So adducts means you're pushing them towards each other, and there's a little mnemonic you can use here because this is D and D right next to each other, so that means they're kind of going to the same direction, and the B and D, they're like opposite, right? So abducts is away, adducts is toward. You get that from the rocking motion. The sliding motion shortens or lengthens the vocal folds. It's either going to make it closer to the thyroid, and the whole vocal folds themselves will be a little bit shorter. If you pull it back, the vocal folds will be longer. And I have a video, as promised, to help show you this. Just for kicks, why not? We can watch this fibroscopy video again to remind ourselves of how this works. I think you've seen this before. It's always a little fun to watch it again. If you don't want to watch it, skip ahead 30 seconds in the video.
The fibers serve to carry light down, to illuminate the folds, and to carry the image back up to the eyepiece and the video camera. The tube is inserted via the nasal cavity.
Okay, cool. Isn't fiber optic technology wonderful? Suddenly that COVID-19 test doesn't seem so bad. Okay, so I will also show you this arytenoids video, which is kind of the point of this little diversion. So, yeah. this is just not going to show you the arytenoids actually, or any sort of phonation happening. He's just going to move his arytenoids back and forth, so they open and close.
Here we are.
Yeah, so I'll play this again and kind of pause it as we go and just say, like, so these are the vocal folds here on the edge of this. This is the glottis. And you can see the vocal folds come to a point here at the front of the body. So this is the front of the body. This is the thyroid cartilage here. And you can't really see the arytenoid cartilages themselves directly because they're kind of as well hidden underneath a mass of like membranous flesh. So they're under here, but they can be moved towards each other or away from each other. So this is the ligamental glottis, and then there's kind of a wider gap back here, which is the cartilaginous glottis.
Here we are.
Yeah, and that's not super pretty, but it doesn't have to be, right? It just has to work. And things of that nature in our bodies are safely hidden away where nobody should ever look at them unless they're doing science, right? Or medicine. So don't worry about that too much. That's just how the system works. How does it work? When the vocal folds are abducted or pulled away from each other, air passes through the glottis unimpeded and voicelessness results. Didn't really show you that in that video, but we'll see it here in the not too distant future. So the way that you get the vocal folds to abduct or the glottis to open is by contracting what are called the posterior cricoarytenoid muscles. So I've got them in two different representations here. I'm going to walk you through a set of muscles that control the various cartilages and features of the larynx. I want you to know them. It turns out they're actually not that hard to remember because each one has a name which directly describes exactly where they are. And then if you know where they are, you can kind of figure out what they're doing. So the posterior cricoarytenoid muscles, they're posterior, so they're in the back of your body. So this is sitting behind the cricoid cartilage. And then they link up the cricoid cartilage, that's the crico part, with the arytenoid cartilages. So here's the link here. And again, with the muscle, when you activate them, the only thing that you can do with them is contract them, make them shorter, right? So that making the muscle shorter will swing these arytenoid cartilages around so that this part swings over here and this part swings this way. And if you do that both sides simultaneously, the whole structure will open. Because these 2 points are going to swing away from each other, and we get that pattern we just saw on the video where we get this kind of V-shaped opening between the vocal folds and a larger kind of gap here in the cartilaginous glottis. Okay, posterior cricoarytenoid muscles, the back of your body connecting the cricoid and arytenoid cartilages. If you want to do the opposite of that, laryngeal action and bring the vocal folds together or adduct them so that you can get phonation to happen when air passes through this narrow gap between the two vocal ligaments. What you do to get that to work is to use two different muscles. The first is called the lateral cricoarytenoid muscle. And so we've seen cricoarytenoid before. That's something that connects the cricoid and arytenoid cartilages, and then the lateral just means it's on the side of your body. So there's two of these, and they're over here on the sides, and if you contract these, it's going to make kind of this distance shorter, so it's going to swing this part of the arytenoid cartilage down this way, and then the opposite end will have to swing back towards the midline of your body, right? Do that on both sides, you bring the vocal folds together. And you can see this guy over here on the side view. This is where it sits in between the cricoid cartilage and the arytenoid cartilage here, this bottom little bump. Okay, that's how you close the ligamental glottis. If you want to close the cartilaginous glottis, or this bigger gap at the top, you get what are called the transverse arytenoid muscles involved, or they may also be called the interarytenoid muscles. Interarytenoid just means they're between the two arytenoid cartilages. Transverse means across, basically. So you can think of it either way. But if you contract this muscle, It's going to make this distance shorter, and it's going to bring the arytenoid cartilages closer to each other. And that'll close off this gap, which is something you need to do in order to get a nice little seal for phonation to happen, sort of phonation to happen in the proper way, as it were, between the two vocal folds themselves and the ligamental glottis. Okay, so those are basic muscle sets for the arytenoid cartilages. The combined forces drawing the vocal folds towards each other produce adductive tension in the glottis. And I think I might actually, I'll walk you through this slide. So adductive tension is just a sort of abstract concept we can think of as a force that's going to push towards the midline of the larynx. How much tension are you putting into the entire system to close the vocal folds? Yeah, I will stop there actually now that I think about it and start up the next portion of this lecture with the following slide. But that's where we're going to go to next, is a discussion of the various forces you can put on the vocal folds when you're actually phonating and what effects that those different forces have on voice quality. Okay, so see you in a minute.